Good afternoon, everyone, and welcome to the statics class. During the past few sessions, we have been talking about trusses, and today I'm going to talk about a new method that we can use to analyze a truss. But before we start the lecture, I have an announcement to make. I have graded your exams and then I have uploaded the graded exams on the course web. Right after this class, I'm going to release your grades so you can see your exams, and then you can contact me if you have any questions or comments. So let's start the lecture. I'm going to share with you my screen. Okay. The topic of today's session is truss analysis by the method of sections. Basically, this is the new method that we can use to analyze a truss. In the previous session, we talked about the method of joints, and basically I explained how we can use this method to analyze a truss. If you remember, we start with finding the reactions using the equilibrium equations. Then we start from a joint, for example, joint A here, and we write the equilibrium equations for this joint, and we can find the forces in these two elements. And then we can move to the next joint and write the equilibrium equations again and find the forces in uh, these two members here. And we can do this for all of these joints and solve the problem and find the internal forces in all of these members. But the question here is that what if I'm interested only in this member? I want to find the internal force in this member CD. And I really do not want to go through all of those time-consuming calculations for different joints. The answer is that basically we can use the method of sections. This is a more efficient way to find the force in the element that we are interested in. To do so, basically we should cut through the truss, and we should make sure that we cut through the member that we are interested in. Here is the member CD, and then solve the equilibrium equations for either the left hand side of the cut or right hand side, and find the force in the member that we are interested in. There are 4 steps that we should go through to find the forces in the member that we are interested in using this method of sections, basically. The first step is similar to what we have been doing for the joints method. Basically, we write the equilibrium equations for the truss, and we find the support reactions using these equations. Then we cut through the member that we are interested in. For example, here we are interested in this member, we cut through that. There is a very important point here, and we should be very careful about it. Basically, we have only 3 equations. We have only 3 equilibrium equations. Therefore, we can solve for only 3 unknowns. So we should cut a maximum of 3 members, because if we cut, for example, 4 members, we will have 4 unknowns and we will not be able to solve them because we have only 3 equations. Then the next step is we should basically draw the free body diagram of the easiest side, because as I mentioned, it has a left hand side and right hand side. We can choose either of them. We can get the answer. However, it's easier to, for example, for this case, to draw the free body diagram of the left hand side because it's smaller and it's easier. And then we consider a tensile force for the members that were cut. Here we cut 3 members, so we consider 3 tensile forces. This is the convention that we all are familiar with. Basically, the tension is considered positive and compression is considered negative. When we solve, the equations, and if we end up with a negative value, we know that that specific member was in compression. And finally, we solve it. Basically, we solve these three equations for the section, either left-hand side or right-hand side, and that I explained, and we can find the unknowns. Is there any question here? Okay then. So let's solve an example. So if we solve this example, I'm sure it makes more sense and you can follow what we have been talking about. We have a truss, a simple truss, and two external forces are applied at point B and F. I have already calculated the support reactions just to save time. Basically, here we have two forces because it was a pinned support, and here we have just a vertical force because it was a roller here. So what we want to do here, we want to use the method of sections to find the force in this member. Okay, so we cut through the member that we are interested in. We make sure that we only cut, we cut a maximum of 3 members, and we consider a force, a tensile force for each of these members that were cut. This is the free body diagram of this part of the truss. We have these two support reactions, these external force, and the 3 members that were cut. Okay, do you have any question? Great. Let's start solving this problem together. First, we should find this angle. I'm going to change the color of my pen. Okay. Theta is equal to tangent inverse of, so you see this angle here is equal to this angle here. So the tangent inverse of 3 over 4. 3 over 4. If you use a calculator, theta will approximately be equal to 37 degrees. And again, if you use a calculator, sine of theta will be equal to 0.6, and cosine of theta is equal to 0.8. Okay, let me change the color of my pen again. Why we did that? Because here we have CD in the y direction, and here we have CD in x direction. And we know that CD in y direction is CD times the sine of this angle here. And CD in x direction is equal to CD times the cosine of this angle. If I write the equilibrium in the y direction, I will have only one unknown. Therefore, I will be able to solve it. Basically, BD and CE are in the x direction, and they don't have any component in the y direction. So I have only one unknown. So sigma F in the y direction equal to 0. I consider upward to be positive. Therefore, this force doesn't have any component in the y direction. I have a 15 Newton here. It's upward, so it's positive, plus CD in the y direction equal to 0. Therefore, 15 plus CD times sine of theta is equal to 0. And therefore, 15 plus CD times 0.6 is equal to 0. Is there any question here? Okay. Therefore, CD is equal to minus 15 divided by 0.6. What I did here, basically, I moved 15 to the right-hand side of the equation. So we have negative 15, and then I divided that by 0.6. And therefore, CD is equal to minus 25 Newton. Since it is negative, we know that CD is in compression. Okay. Is there any question here? So you can see that how quickly we were able to find the force in this member. We really didn't need to solve all of those equations for this point or this point here, or we really didn't do anything regarding any of these on the right hand side of the cut. Okay, so for next session, what I'm going to do, basically, I'm going to talk about the appropriate cuts for different types of trusses. As it was explained in the previous sessions, we have different types of trusses, basically Warren truss, K truss, roof truss, or Pratt truss. And there are specific types of cuts that we can use to quickly solve those problems. So I'm going to explain them, and I'm also going to solve different examples on those different types of trusses. I have designed a homework for this topic. Basically, as you can see here, we have a truss, a simple truss. I have already calculated the reactions. External forces are given. And then I would like to ask you to use the method of sections to find the force in this member here, member BE. And the hint is that basically you should cut through this line. It cuts only 3 members, so you can solve it for 3 unknowns. And then you can find the force in this member here. The due for this homework is Friday. I'm going to upload this homework on the course web right after this class. And if you have any questions or any comments, you can either email me or you can stop by my office and we can talk more about that. Okay, I'm going to stop sharing the screen. Thank you very much all for your attention, and please let me know if you have any questions.